Okay, so let's talk about the final subject or the final slide of chapter 4, the IP services chapter, the most loved chapter for me, the FTP protocol. FTP or file transfer protocol, the protocol that we will talk about right now, is one of many protocols that do transfer data, files, whatever this type of the file is, between network devices. And mostly it will be between an FTP server and client. Or actually, this is the only case that you will use. You will have an FTP server in your network, which is a server. It can be a desktop, whatever device you have. You need to enable FTP server on this desktop or on this server, this normal server in your network, and install or store actually some files and data in it. And after that, make your network devices as FTP clients. This will grant something very important to all your network devices, which will be now you can transfer data, iOS images to upgrade your network devices, startup configuration that's saved as TXT format. All of these things can be transferred from this server, from this FTP server, to the network device that you have. Okay, so this can devices transfer data between them, yes, using the FTP. Data like files, normal files, software images, configs saved as text, all of them can be transferred using the TCP 20 and 21. Why it's and you have always talked about a protocol has UDP port X or has TCP port X or Y, and that's it. So why now there are two ports for TCP? Okay, two TCP ports for two reasons. If you just got me, what I mean so far is that you have a server, an FTP server in your network that is connected maybe to a switch and which is connected to all your other devices in the network. So what will happen is that you can access to this router, and from this router you can require to copy a file from your router to the server and after that to another device, or maybe you can require to copy something from the FTP server to your network device, router, switch, or whatever you would like. To do so, you would need a transporting protocol. Actually, transport protocol, by the way, they are FTP, SCP, which is secured more than the FTP, and the HTTP is also used for transporting. But what we are talking about right now is only the FTP, the file transport protocol, transfer protocol, not transport, and FTP uses TCP port 20 and 21. Why? Because just in case between this FTP server and this FTP device, the client, this one in here, two TCP ports will be reserved for the FTP transfer. TCP port number 20 and number 21 at the time you are configuring or making use of the FTP. TCP port 21 is called a control channel, to establish a control channel between the server and the client. Okay, the same thing that I've just mentioned, I've just wrote it before. It's only for establishing control, to perform the three-way handshake and to make sure that there is a connection, valid connection between the server and the client. So after that is validated correctly, you can start transferring files, but this time using the TCP 20, the data channel that will transfer the real files between the FTP server and the FTP client. So you have two channels, the first one for control and it transfer the authentication. There are some data transferring between them for authentication and for the authentication and making sure that the connection is correct or established correctly between the devices. After that is done and established correctly, the other channel, the data channel that uses TCP number 20 between the two devices, will start to really transfer data. Data will be like iOS images, which is the most important thing that you will transfer in your network using the FTP protocol, because what you will face actually in your network will be you have one FTP server only, and that FTP server is connected to the entire network. Maybe your network has from 10 up to 100 device, and let's say from this 100 device you have 40 routers. All of them are the same model. Maybe all of those routers are some type of very strong routers called aggregated services routers, like 1000 series, and let's consider 1001, one of the most devices I've ever worked with it before. Maybe I've worked with like 51 of them. Anyway, so the ASR, or the aggregate services router from Cisco, you have maybe like 41 of them, all of them the same model, all of them 1001 in your network, and there's a new software release. What you do is that you go to Cisco portal to download this software. After that, you take this software and you store it in the FTP only. You don't have to transfer this software image, new software image, to all your devices using like USB stick, because this is the only way you can do it. Or the other way is that you can store this new image in this FTP server. Inside the FTP server, there's an IP address for this FTP server. By the way, there should be reachability between both of them, just like SSH we have talked about in the previous video. There should be IP address for this FTP server, of course a valid IP address for this device, reachability between both of them, and there must be an authorization level for the FTP, which is username and a password for this one. So you will go from your device, you will store the image here, copy, and you will go from your device and you will type the command of copy from FTP server, which has the IP address, I believe it was the username of, which is the username of the server, at the IP address, which is the IP address of the server. Hit enter to, or maybe space, and the name of the file that you want to copy. Actually, the CCNA just said describe FTP and its purpose with no config, simple config, nothing much. You can do it in packet tracer, but anyway, after that you can give it the name of the file that you want to copy from the FTP server. After hitting enter, it will ask you for the password of the FTP, because yes, it found such FTP server that has such IP address, and it was half accessed by using the username, but only the password left. So please give me the password if this is the one you are talking about. Type the correct password. After that, it will ask you one last thing, is that you want to copy this file name from the FTP server to where. So I have to, after the space, maybe say to the flash of my router, to store it in the flash of my router, or maybe in the boot flash. It depends on the storing unit that you want to store the file in. It will ask you then one last question, really one last question will be, you want to copy from FTP that has this username and password and IP address, this file name to your flash, but after copying, what would the name of the file be? Would you like to keep it the same? If yes, hit enter. If no, you can change the name. After that, hit enter. The transformation will start. Transferring process, I'm sorry, will start actually, and it might take seconds or minutes depending, or maybe hours depending on the size of the file that you are transferring. After everything is completed, you will find your device, I'm sorry, the iOS image or the data, whatever you'd like to transfer, has been completely transferred from the FTP server to the client. You can do this on your network using automation that we will talk about in chapter 7. I have 50 ASR in my network. I want to upgrade all of them, so using automation I can do the copy of FTP at the same time for 40 device. I can validate the image for the same time for 40 device or 50 device, all my devices, and I can also schedule auto software upgrade for the devices at the time I want and at the criteria I want. This is we will talk about in the automation chapter 7 in the end, but before automation you have to upgrade your device manually. Okay, you can instead of transferring the new iOS image using a USB stick for each device locally, you can thing to FTP, use it remotely from where you are sitting. Just access your devices and copy the iOS image from the FTP server. It will be then distributed to all your networks, all your network devices. But after you distribute it to all your network devices, you need to upgrade it manually, upgrade your devices manually. In automation, this will be automatically. We will talk about this later. So one last thing before I finish will be, there is a fast flavor of FTP. I need my red pen back, which is called, there is a relative for FTP which is called the trivial FTP, known as TFTP. The difference is that TFTP uses UDP 69. Yes, it's unreliable, but still has its uses in the network. You will use it rarely, I believe, in your network, because I have never used it. We only used FTP in trusted networks. And if you want even more secured transferring protocol between devices, you will use SCP, because it's more secure than FTP. But what's mentioned in the new CCNA is only FTP, not even really even the TFTP, and not SCP at all. You must know FTP, the big benefit of the FTP, and that's it. So far this is the official ending of chapter 4, IP services. I hope you have liked this chapter, because this chapter makes you, or actually gives you, the entire big image of the networks. That networks are not just devices connected together using physical layer applications like cables, and not only data link applications like MAC addresses between them, which is something automatic at all, and not only network applications like IP addresses and that's it, IP connectivity, not even for routing protocol. This is not enough at all for just to establish 40 devices, connect them together, establish like a static route or maybe OSPF with some VLANs inside, and that's it, everyone will reach everyone. No, at all. There is a big chapter called IP services, and this chapter has 9 subjects. We have talked about 9 subjects mentioned in the blueprints of Cisco. So there are 9 protocols that you must, or maybe mostly you will use all the 9 of them in your network. You will use SNMP, NTP, definitely not if you want internet, definitely DHCP for distributing IP addresses, maybe FHRP if you have redundancy. You must have redundancy, please. You don't want to go none, from one to none, as I mentioned before. Syslog, NTP, SNMP I've talked about, FTP, quality of service, and SSH, of course. So those 9, they seems all like mandatory. They seems all of them must be installed and configured correctly on your network, so that your network is secured, easy to manage, easy to use, give really good quality of service, and really good data and services served to the customers, and that's it. So this is the end of chapter 4 officially. I hope it was beneficial for you. I hope it was useful for you. I'm sorry, I think I had confused with some subject in chapter 4. I don't know why, because I'm recording 2 chapters at the same time. I don't want to do some blah blah a lot to you, cause you some headache. And that's it. I will start recording chapter 5 after that directly. I hope I get to explain chapter 5 better than chapter 4. It will be all about security, so it's entirely new chapter for the CCNA candidates, because there was no security in the previous CCNA, but there was the CCNA security, which is the one alone on the left, or maybe this is your right. Okay, there was a CCNA security separated certificate with a separated exam and books, official student guide to study, and labs, specific labs to prepare and perform practice. But now there is no other CCNAs, there is only one CCNA, so there is an entire chapter of security in this new course. So we will talk all about security in the upcoming chapter. Thank you for watching and your patience and all your time until now. I hope all of it worth it and worth all the efforts I'm giving, and hope to see you in the upcoming chapter. Goodbye and thank you again.